Hi everyone, this is the last portion of 3.3 notes. We've been taking them in class, and now we've got a video for the last three examples. So today we're going to talk about slope, and that's something that we've been kind of inching towards through all of 3.3. We are looking at rate of change earlier, and then now we're introducing this concept called slope. Slope is specific to linear functions. So we could even say that it's the rate of change in linear functions. The rate of change in linear functions. So slope really does equal rate of change, okay? These are the same things that we're talking about, but slope is a constant rate of change. So that's what kind of sets it apart, and that's what allows us to do some special things with it. Slope is also known as the steepness, and you're going to be thinking of like ramps and hills and things like that. So one way that we describe slope is the ratio of the rise to the run. And the rise is the vertical change, so the up and down. And then the run is going to be the horizontal change, which is side to side. And what you might recognize from that is when you're talking about rise up and down, that's what the y-axis is. So when you're talking about rise, you are literally talking about the difference in your y's. And then when you're talking about run, it's horizontal, just like the x-axis, and it is literally looking at the difference in your x's. So this equation, this rate of change equation, is going to be exactly what we're using for the slope equation. They're going to be the exact same thing. Maybe you've noticed that we've been writing rate of change, and we've had to write it out the entire word for word, long, terribly long 3-word, phrase. Mathematicians, as you know, like to abbreviate. So just like we have A for area, we are going to have a letter that is specially designated to slope. And it's a little bit of a shocker, but it's actually the letter M. M is going to be slope. So your M is your slope, and you're using the same rate of change formula, okay? So we have this really cool thing that we've been really doing the entire time, but we haven't necessarily talked about it. When you think of it as a rise over run or a change in y over change in x kind of thing, if you're looking at your rate of change or your slope, you can look at a graph, and without using that formula, the rate of change or the slope formula, you are able to calculate what the slope is by just knowing those 2 points. So I know that some people have noticed this and have started to use this already. You count the number of units up to get to like the same vertical level, the same height as your second point, or it could be down to get to the second point. And then you're going to count the units that you need to move horizontally to get to that second point. So this is the run, this is the rise, so rise over run, and you would be using your x1 and your y1 kind of thing, x2, y2, and it's going to be the whole thing. Lines up perfectly with this. Very cool, very interconnected. We've got lots of different ways that we can express slope because it's so important and so cool, okay? There are different types of slopes. So that's going to be our example 4, is looking at three of the different types of slope. There's actually 4, but 3 of them are pretty similar. So the first ones are positive, negative, and 0 slopes. So what I'm going to do is I'm going to take the rate of change, now called the slope equation. So I'm going to put m equals my change in y over my change in x. And then I'm just going to plug in these values. Now remember, my ordered pairs are always in that form. So x1, y1, x2, y2. I've already been writing things that we were using the table in earlier examples. I've been writing them as ordered pairs. So hopefully you kind of feel comfortable with taking them from the ordered pairs and putting them into the equation. And if not, you're going to get plenty of practice, okay? So we start with our y's, which are 2, and then minus 5. And then I have x1, which is negative 3, minus, okay, also 5. So when I go through this, I get negative 3 on top, and then I have negative 3 minus 5, which gives me negative 8 on the bottom. I've got the negative on top and then negative on bottom. 2 negatives are going to make a positive in this case, so that cancels out, and I get 3/8 as my slope. This is pretty cool because this actually means a rise of 3 and a run of 8. So I have a horizontal change of 8 units and a vertical change of 3 units. Very cool. The other thing that we want to pay attention to that can be kind of easy to overlook is that this is a positive 3/8. This is a positive slope. So if we're going up 3 and then we're going over 8, we've got a slope that's kind of like that. Very, very general drawing there, so don't take it too seriously. But if it had said like minus 3, I would go like down 3. Okay? And then minus 8 would be like back this way, because that's the direction on the number line. Make sense? So this is a positive slope. All right, let's look at this one. This is going to be, don't want to spoil it too much, but it's an example of the negative slope. So I recommend always writing your original formula so that you can do as little jumping with your brain as you possibly can. It's nice to have it right there. I also recommend labeling x1, y1, x2, y2, and then this way it's really just like plugging in whatever you've decided is y1 and so on. For this one, I have minus negative 8. It's very, very important and very easy to forget that you have a subtraction sign, especially when you have a negative 8 that you are subtracting. You have to remember those double negatives. They are very important. Okay, and then we have -3 minus, and then I've got a -2 for my second x. Okay, so that is a bunch of double negatives that are going to turn into some addition problems. So I have -4 plus 8 over -3 plus 2. And then when I evaluate that, I get 4 over, that'd be -1. So that's -4. So for this one, my slope is -4. As you can see, it's a negative sign. And this one is interesting when you look at the rise and the run, because we're saying it's a rise of 4, but a run of -1. So what's kind of happening here is, in the same way that I had the +3 and then +8, I'm going up 4, but then instead of going forward 1, I'm going backwards 1. And that's going to leave me somewhere like that. So this is a general idea of what your negative slope would kind of look like. All right. Now let's look at zero slope. How is this going to look when we see it in the wild, right? M equals y1 minus y2 over x1 minus x2. I'm going to have 4 minus 4 over, I forgot this, 4 minus 4 over -3 minus 4. Okay, well, 4 minus 4 is 0, and then I have -7 on the bottom. But this is really just a slope of 0, because that's what that would simplify down to. So this is a slope of 0. This is meaning a rise of 0, so no vertical change. And then we have a run of -7. So no vertical change is very, very important here. We are only going back and forth. The x value is the only thing that is going to be changing if you have a slope of 0. Y stays the same. All right, you guys. So here's a couple try problems for you. Go ahead and pause them. I will give you a hint. This one you should end up with a positive slope. This one you should end up with a negative slope. And then I guess I give you guys the answers usually on these, don't I? So this one would be -2 once you finally get it. And the other one should be 1/3. Okay? So see if you get those. And I will see you on the next video. Okay? Bye-bye.